Good morning, ladies and gentlemen. My name is KWAK Woo-Young from Hyundai Kia Motors. Today I'll be talking about the evolution toward smart cars through ECOllaboration. Usually when we use the word smart, it's defined as follows. It's a technology or device that provides a value that is much more than we expect. As a result, we have many smart devices around us, smartphones, smart TV, and even smart glasses. So we call these smart devices. There are many of such smart devices in our lives. Then what does a smart car look like? Many people talk about smart car, but they talk about it in a different way. So let's look at it. Do you think this is what a smart car is? A smart device plus car? We also have a smart home. No, that's not it. Nevertheless, that's how many people define the smart car. Various IT technologies and IT devices are attached to the car. That sounds plausible, but this is what you get when you do that. Is this smart car? We all know that it's not. Then we need to have an accurate understanding of what smart car is, and that will allow us to know what we need to do to evolve into the smart car. That means starting by understanding the characteristics of the automobile. So let's look back in history. In 1886, the first automobile in the world emerged. This is the officially registered automobile, and it was the Benz. It had one cylinder and a combustion engine. So it had the looks of the automobile, as we know, but it was very expensive and took a long time to produce because it was manufactured by hand. So those who were used to the horse-led carriages thought that it was useless because it was too expensive. But technology continued to evolve, and finally in 1908, the company Ford of the US produced the Model T. It was the beginning of mass production. The conveyor belt carried the cars, and a lot of the machines were automated. Afterwards, about 15 million Model Ts were produced for the American consumers, and it accounted for 50% of the automobiles in the world. Afterwards, other technologies appeared, semiconductors, IT, and mechatronics, which is a combination of mechanical engineering with electronics. This is how we arrived at where we are today. Already many of the functionalities are implemented through software. About 90%, I believe, are implemented through software. And 40% of all the parts that go into the automobile are electronic parts. There are about 25 to 30,000 parts in a car, and many of them are electronic parts nowadays. That's the history. In the beginning, automobiles were used for transportation. No question about that. It replaced the horse-led carriages. But as it became more popular, nowadays, it has become a living space, a private and personal space for the driver, the passengers, and the family members. Some women even put on their makeup in the car. Some truck drivers eat their meals in the car. So the paradigm is changing. As the automobile industry advanced, other issues emerged at the same time. One of that is the increase of automobile accidents. According to the 2010 data, 670,000 car collisions took place in the U.S. The car is a very heavy machine that moves at a very fast speed. So the motor energy that is generated is enormous, and more car collisions are taking place. Secondly, driving can be a very boring experience and tiring as well. People are used to texting friends and connecting to the social media. But when they are driving, people feel that they are disconnected from the rest of the world. Another issue is the depletion of a fossil fuel, which is used as the main energy for moving automobiles. Crude oil is refined for diesel and gasoline. That is what the automobile uses as fuel. So it's a big issue. In order to overcome such issues, first of all, we need to look at the value of safety, a very important value. It's a factor, but also a value. Protecting passengers, reducing the number of accidents, and protecting human lives is a very important value. Secondly, making the car more convenient and enjoyable is another issue. Reducing fuel consumption and realizing zero carbon emission will help improve the environment. These are the three major issues and values that we need to address. So let's look at safety first. There are two types of safety issues. One is passive safety and second is active safety. The criteria is whether the safety device addresses moments before the accident or after the accident. A passive safety is about devices that protect the passenger after the accident has taken place. And the most representative device of such kind would be the airbags. The shock is first absorbed by the car chassis because it crumples up. But then there's the airbag that absorbs the second shock. We have inflatable airbags nowadays, as well as inflatable seatbelts for young and old passengers. There are also airbags that pop up in the windshield and protects the pedestrian when the car hits the pedestrian. There's also an active hood lift that's under the hood and lifts up the hood once a shock is felt by the car. But more importantly, it's best to prevent accidents, and this is what we call active safety. As you see, we use a camera to address the issue of blind spots. And when you drive at night, it's difficult to see ahead. This is when the camera is used to show whether there's an object in front. There's also a device that alarms and alerts the driver by using a vibration technology when the car rears off the lane. To prevent a collision, a smart technology is available that reduces the speed of the car automatically when an object becomes closer. But if you look at all of this, it all happens within the space of visual information of the driver. In other words, everything that is nearby the driver. But many things are very far off. For example, multiple collisions. That's why we need better technology. Let's take a look here. This is what we call active safety. and it's called V2V for vehicle to vehicle and V2I for vehicle to infrastructure. Finally, cars are communicating and talking to each other, and the vehicles are talking to the transportation traffic control system. That allows the vehicle to receive the information that the driver is not aware of. We have wave technology, which is an advanced DSRC technology. Dedicated short-wave communication is DSRC. We don't have to communicate 10, 20 kilometers far away. We just need to know the adjacent area information. By attaching such device to the vehicle has an exact idea of its location. So we attach a very precise GPS, so that the traveling direction and the exact location is communicated. The cars with the receiving devices collect that information and acts like a radar control tower. Just like we look at all the moving airplanes, my map shows all the cars that are moving around me. This project is underway. It's being researched in Japan, US, Europe, and at Hyundai, we are taking part in the Department of Transportation project. We have 8 OEMs in the camp, and we're playing a very important role. In August last year, we had a meeting to start the second phase. I was at that meeting, and a very distinguished congressman went on stage and said that finally the cars are talking to each other. We need to learn from them. People are not communicating well. This is what the project is about. With this project, we have 3,000 vehicles in Ann Arbor that's in the pilot phase. Now I'd like to show you 2 issues. One is in the intersection, and second is about multiple collisions and preventing multiple collisions. So I'll show you 2 video clips. This is what takes place in the intersection. The car which is at the intersection is unable to detect the car that is approaching, but by using the V2V technology, the signal is received and action is taken. The alarm alerts the car, so the car will stop and resume driving after that car has passed. The second scenario is what we call an emergency brake. The first car stops, and the car far behind will also receive signal and stop as well. As you can see, 3 cars are traveling, and the first car puts on the brake suddenly, and that signal is sent to the car in the far back. Sometimes it's very foggy, and under such conditions, many cars will collide. So this sort of accident can be prevented. A more important and more smart technology is available as well. That's what we call an autonomous driving technology. It's an unmanned vehicle, in other words. As you can see, there are 3 images on the left-hand side. First is the autonomous driving car made by GM. The second is made by Google, and the second is made by Volkswagen. And the large image is the autonomous driving vehicle made by Hyundai. There are many things on the rooftop, right? But look at the car. It's quite clean, and you can just use it now. That doesn't mean we're going to commercialize it immediately. We're going to take time, but right under the headlamp, we have what we call a rider, which is a laser scanner that looks at, that detects all the objects in the front side of the car. There is a camera in the windshield area that detects all the obstacles before the car, and there's a GPS antenna on top of the car to assess the exact position of the vehicle. Based on all the information that is received, the car is decelerated or accelerated. That is done by a brain which is attached on the trunk of the car. Of course, I can't stop my talk here. I need to show you how it actually looks when it's in operation. This is the first time that we reveal this video. It's moving at a very fast speed. It will avoid obstacles. And as you can see, it does very well on an unpaved, curved road. And it has arrived at its final destination. This is when you should applaud. Next, let's talk about the value of convenience. I'll show you a video clip as well. Thank you. This is a concept car called Nymer made by Kia Motors, and these are the convenience features that come with it. It's a long video, but we edited to make it shorter. There are many technologies involved: location sharing, voice recognition, purchasing music on the App Store, and loading it onto the vehicle. These are many technologies that enhance convenience. There are four major areas of such technologies: the user experience enhancing technology, and cloud services, telematics, that's about safety and passenger protection. The fourth area is connectivity, bringing the IT devices into the car and enabling connectivity. Let's look at connectivity in more detail. There are many different types of technology: Bluetooth, Wi-Fi, MirrorLink, Mirrorcast, MHL. These are various technologies related to connectivity, and a consortium is formed including all of these technologies. Let us now look at the value related to environment. We have hybrid, plug-in hybrid, and electric vehicles that are commercialized. Hybrid vehicle combines battery and combustion engine to economize fuel consumption. So what happens? But it does use fuel. The vehicle that does not use any gasoline at all is the electric vehicle. But there's some problem with the electric vehicle. Once it's charged, it can only travel for a limited distance because there are some limits in the battery. So it can't travel far distances. So what's the alternative? That would be the fuel cell electric vehicle. At Hyundai Motors, we have gone into volume production of this fuel cell EV. We are the first in the world. Once charged, it can travel for 600 kilometers. Maximum speed is 160 kilometers per hour, and the acceleration, in other words, the time it takes from going from 0 to 10 kilometers per hour, is only 12.5 seconds. It emits zero carbon. The fuel cell is the core technology. It combines hydrogen and oxygen, which usually don't react. But once it is made to react by using a catalyst, then it does react and it produces electricity in this process. In order to go into volume production, we went through many reliability tests and made sure that it was feasible in terms of cost as well as functionalities. This is the future of eco-friendly cars. So we looked at the three core values: safety for intelligent and safe drive, convenience for connected life and easy to use, environment for clean and green mobility. These values are combined to produce a smart car. The smart car, as you can see, involves many factor technologies. These are core technologies from many different industries, but these industries have been combined, crossing borders between the industries. So it is a cross-sector, open innovation. The automobile industry accounts for 12% of total manufacturing, 13% of exports, and 11% of employment. So the automobile industry is a national industry. The Hyundai Kia Motors Group is aware of the importance of the automobile industry, and based on a mission and a sense of responsibility, we will continue to work so that we become globally competitive. We look forward to your continued support and interest. Thank you.